Kia ora, everyone. We're here looking at one more superpower that classes have up their sleeves that we haven't talked about yet. We've seen so far how to write a class. We've seen how to initialize a class with this init function. We've seen how to give it properties. We've seen how to give it methods. We've seen down here how to create an instance of a class, of an object, and we've seen how to call those methods and use the properties. But one more superpower that they have up their sleeve, which creates so many more options when you're looking at using classes and making classes and getting them to interact, which is inheritance. What do I mean by that? Well, at the moment, we have one class in this code that we've written so far. And if we run it, I've changed this a little bit just so we've got 5 balls on the screen. Nothing else has really changed. Just 5 balls bouncing around the screen. Great. They've got an X position, a Y position. They've got a velocity. They've got a color. They've got a radius. They've got a... it's the background. You know, they've got 2 methods, one of which is an update method, which changes their position and checks if they need to bounce, and the other method is the draw method, which draws them onto the screen. That's our ball class. But let's say I wanted another kind of shape. Let's say I wanted a square. I might want to write a square class, and so I go class square. Of course, class square like that. Now, just like we've got class ball here, and we've got the keyword class, we've then got ball as the name of the class, then these brackets here, these empty brackets here, and then a colon as our how we actually the syntax for declaring a class up there. These regular, normal, round brackets here, they contain the parent of this class. At the moment with our ball class, they're currently empty because ball has no parent. It is inheriting from no other class. But let's say I want to inherit all of these methods and properties from this ball class. I don't want to have to go, oops, there it is, it finishes there. I don't want to have to go and write them all out again. I just want to grab all of that stuff and make a new thing which is like a ball, but a little bit different. I can inherit all of that code just by putting ball in there. And it's going to throw an error at me because, of course, up here, as we run through the code top to bottom, ball isn't defined yet, so I have to come through and cut that out and put it underneath my ball class. So if I put it in there, what this is saying is we're making a new class. Its name is going to be square, of course, capital first letter, and it's a child, or it's going to inherit all of the methods, all of the properties from ball. It's going to be a child of ball. Ball is going to be its parent. What does that mean? I can just put this here, pass, and I have to put pass as in I don't want to do anything. I'm not going to give this class any code whatsoever. I'm not going to give it any methods. I'm not going to give it any properties. Just pass, do nothing. Can I still use the class square? Okay, well, I tell you what. Let's get rid here of all of our code for generating, actually making instances of ball. So I'm just going to go command / there and comment the whole thing out. Highlight command /, very handy trick for commenting things in and out again. And it's uncommented, and it's commented, and it's uncommented, and it's commented. Off, on, off, on. Good trick. Okay. Let's make a ball. Not a ball, a square. Let's make a square. So I just say, let's go square small s. Oh god, maybe this is a bad name. Maybe let's call it. Let's give it a silly name. Simon. Simon is our square. Okay, great. And Simon's going to have a small s because he's a variable. Okay. Look what turned up. What is this? Whoa. X, Y, velocity X, velocity Y, radius and color. But that's not in our square class. Our square class has nothing in it. It doesn't even have an init function. It doesn't even, can't even initialize it. Where is that all coming from? Of course, it's coming from its parent. It's coming from our ball class all the way back up here in its initialize function. Because we haven't given square its own initialize function, it's looking back up the chain of hierarchies, looking to its parent to find its init function, and it's looking for that and it's saying, hey, yo, user, coder, programmer, you need to give me an x, a y, velocity x, velocity y. So let's do that. 100. Velocity x is going to be 4, velocity y is going to be 5. Radius, which sounds a little bit weird for a square, but let's just go with it for a moment. We'll change it later. Let's make that 50. And color is, I don't know, a nice yellowy color. Cool. Let's see if Simon shows up. No, it doesn't. Can you spot the error? Because, of course, I've made Simon our square, and I haven't actually done anything in the onDraw function to say, hey, update and show this particular object. So let's do that. Let's comment that out for now. Do our cool trick that we learned before. Comment that out. Don't need to show the balls on there. We want to show the squares is what we want. We want squares. Okay, so let's go Simon dot draw, but we'll actually put update above it because it weirds me out having the draw function above the update function. Simon dot update is what we want. Let's run it. Excellent. Hey, we have Simon here who has a class of a square but is actually inheriting all of that information from the ball class. Can you see a problem? Simon's not a square. Simon's a ball still. How do we make Simon a square? Okay. First things first, let's deal with that radius thing. So, balls have radii, squares do not. How we're actually going to fix this is we're going to change radius to size. So let's go to click here, and something that's really, really, really handy, change all occurrences. So you see there's all of these occurrences of radius. We're just going to go and we're going to change that to size. So there we go. That should have fixed this. Did it bring in any bugs? Always worth checking. No, still working fine. Great. Okay, so our ball still has a property called size now, but we want to change the draw function because we don't want to draw a draw a ball. We want to draw a square. How easy is it going to be to change? Well, what we can do is we can overwrite that draw function from that we inherited. We inherited a draw function from our ball class. We can overwrite that in our square class. So let's define draw, and draw is going to be arcade dot draw square. Do we have a draw square? We probably have a draw rectangle filled, and it's going to have a center X of self.x. Self.x. It's going to have a center y of self.y. It's going to have a width of self.size. And it's going to have a height of self.size. And it's going to have a color of self.color. Excellent. Okay, it's complaining at me. Why is it complaining at me? It's not defined. We haven't run the init function here. So we actually do have to do this, where we're going to do the same thing. Oh, and we need to put in... Did we need to do that? Or did I just forget the self? Is that what it was talking about? I just forgot the self. We don't need to define the initialize function because it's going to run that automatically. It's going to run this double underscore init function that it's inherited from our ball class automatically and gain all of these variables in itself. I just forgot to put self in its method when I was defining it. Silly mistake. But here we go. So what we've done here is we've overwritten that draw method that existed in our ball class. Here you see it here. Maybe I can just get a little bit more code visible so I'm not jumping up and down the code so much. So here you can see our ball class has a draw method, and our square class also now has a draw method. And this square class is going to overwrite the draw class of its parent. Let's give it a shot. It's a square! Success! Excellent. We have a square. The bouncing's looking a bit funny, but it's close. Now, can we have both balls and squares? You betcha. Multiple balls and a square. Can I have multiple squares? Well, let's go S equals all of that. Copy this in here. And rather than making this a ball, let's make this a square. And let's append from balls, let's append B and let's append S in this loop. And calling this balls is a little bit weird now, so maybe we should just do our right up to the top where we defined it. We should say change all occurrences again. Very handy tool. Just delete it and let's call it shapes. So shapes is going to equal that, and let's run it. I should now end up with 5 balls, 5 squares, all bouncing around. Success! How cool is that? We even put them in the same list because the draw function was called the same thing in both our circle class and our square class. We could just call it in a loop. And all of the logic sorted itself out. How cool is that? Your challenge, make a third shape. Make a triangle. Make an arc. Make anything else. And also, another challenge for you to do is to fix up the bouncing of the squares. So there's something going on in their update function because they have the exact same update function as the ball class. They've inherited that from their parent. What you can do is you can overwrite that update function with a new one, which is going to make the square bounced perfectly off its edges. That's your challenge, and I will see you in the next video. Ka kite anō.